Hello, fellow problem solvers. So today we're going to be doing a problem that is quite dear to my heart. It is the problem from the JBMO Shortlist 2014, problem A1. JBMO being the Junior Balkan Math Olympiad. Now the reason this problem is quite special for me is because this is my first proposal for a competition that actually passed to the shortlist. So I invite you to take a minimum of 10 minutes, ideally half an hour, but not more than an hour and a half to solve this problem. If on the other hand you'd like to go along with us, I suggest you take 5 minutes and push the problem as far as you can and put your first ideas out on paper. So now, let's begin. So the problem is quite simple. It says find all n in the positive real numbers such that n plus the floor of the square root of n plus the floor of the cube root of n is equal to 2014. Now, I am biased, but I think this is a wonderful, simple problem statement. And what the first idea is, okay, so noticing that this thing right here, the floor of something and the floor of something, these are integers. This is an integer and this is an integer. And now because this is an integer, that implies n must be an integer. So we've already narrowed down our solution space. Namely, we know that because of this, we know that n is an integer. So now, what are we going to do? I invite you to take about 5 to 15 minutes and get your next idea out on paper and try to push it further, perhaps even solve the problem. So one way people did this is they said, oh, this is a strictly increasing function, so there can only be one solution, and then they guess the solution, and then they say yada yada yada, this is done. I don't personally like that. That's not why I made the problem. So the idea is, how do you get to a solution? How would you find a solution yourself? Then let's translate that into math. So we have, what do we know about n? N cannot be greater than 2014. So we know that n is less than 2014. And we know it's greater than, say, 1,000. We know it's greater than 1,000 because the square roots of 1,000 plus the cube roots of 1,000, the floor of these things, plus 1,000, this is going to be less than n plus this, and this thing here is greater than or equal to 1,000 plus 32 plus 10, and this is going to be less than 2014, so we are good. This is correct. So n is greater than 1,000, less than 2014. And now let's work with this. So we know n is less than 2014. What does that tell us about the floor of the square root of n? Well, it's less than the floor of the square root of 2014. Actually, it's less than or equal to this floor, because they could be the same. And this thing right here is less than, strictly, to the floor of the square root of 2025, which is equal to 45 squared. I.e. the floor of the square root of 45 squared, which is 45. And we also know that the cube root of n is less than or equal to the floor of the cube root of 2014. And now we need to find the appropriate cube. Luckily for us, cubes grow quite quickly, so we can just even do a very bad estimate and say this is less than the cube root of 8,000, which is equal to what? This is the cube root of 20 to the power of 3, which is 20. So now we know that n, which is equal to 2014 minus this, is going to be what? Well, when we move these to the other sides, we know that the negative of the floor of the square root of n is going to be greater than or equal to negative 45, and we know that the negative of the cube root of n is going to be greater than or equal to negative 20. So we know this is greater than or equal to 2014 minus 45 minus 20. And this thing right here equals 1,949. So now we know about something about n. We know n is greater than or equal to this, and it's less than 2014. Can we further decrease what n can be? Mind you, here we had is between 1,000 and 2014, and now we know it's between this number and this number. I invite you to take another 10 to 15 minutes and try to finish the problem yourself. The thing is, given this, we can actually figure out what n is directly, and here's why. We know that the square root of n, the floor of this, is less than or equal to the floor of 2014. This, just due to this thing. And we know this is strictly less than the floor of the square root of 45 squared, which is 45. Now, what is 44 squared? Well, this is 45 minus 1 squared, which is equal to 45 squared minus 90 plus 1. And this is 225 minus 90 plus 1. And what does this give us? It gives us 1936. So we know this is greater than or equal to and this is 44 squared, 11936. So the square root of 1936, which is 44. And due to this thing right here is an integer, and it's less than 45 and greater than or equal to 44. That means that we know that the floor of the square root of n is equal to 44. And now how do we figure out what the cube is? Well, we know that 12 cubed is 10 plus 2 cubed is 1,000 plus 600 plus 120 plus 8. And we know this is less than 1900. And on the other hand, we know that 13 cubed is going to be 10 plus 3 cubed. And this is 1,000 plus 900 plus 2,700, I think. No, it's 270 plus 27. And this thing right here is greater than 2014. So now we know that the cube root of n, the floor of this, is going to be less than or equal to, actually strictly less than, the 13 cubed. This thing right here, we know it's greater than or equal to this thing right here. So now we know that the cube root of the floor of n is going to be equal to 12. And now with these two things, what we're left with is that n is equal to 2014 minus the floor of the square root of n minus the floor of the cube root of n. And this is going to be equal to 2014 minus 44 minus 12. And this thing right here, so this is minus 14, we get 170 minus 12, 1958 is the answer. And as always, thanks for problem solving.